sir. My name is Sean Michael from the Sacred School. And my name is Nachiket from Sacred School. As the world is talking about sustainability and the green concept to sustain the natural resources for the next generation, a lot of research has been done by many industries to sustain the energy as well as enjoy the technological advances in today's world. As you can see here, most of our energy sources such as natural gas, coal, oil are non-renewable. So we need to use more renewable energy sources such as solar, biomass, etc. And now we are talking about the hydrogen, which is going to be a secondary source of energy.
According to the U.S. Energy Information Administration (AIA), transportation accounts for 26.6% of global consumption of energy and also is the second largest producer of carbon dioxide emissions.
On the previous data, Alstom have done a research on which automobile gives out the most carbon dioxide. And it is sad that cars give out 115 grams of carbon dioxide per passenger per kilometer.
Due to many people now able to afford cars, this has led to a massive increase in the number of cars on the road and therefore more carbon dioxide was produced. Therefore, our project for today is the hydrogen fuel cell.
The fuel cell consists of a solar module, a car chassis with an electric motor, a PEM fuel cell, which stands for proton exchange membrane, reversible proton exchange membrane, a fuel cell, which acts as an electrolyzer and a fuel cell, and banana plug.
This is how it basically works. The solar module uses the sun's energy, it converts it into electrical energy, which then powers the electrolyzer to electrolyze water into hydrogen gas and oxygen, H2O, hydrogen and oxygen, which then the fuel cell uses the hydrogen gas as a fuel to produce electricity and thus power up the car.
On the inside of the fuel cell, there is an anode, a cathode, and a proton exchange membrane which is sandwiched in between.
The fuel cell works on a very interesting technology, very basic chemistry, that oxygen and hydrogen combine to give water. Therefore, hydrogen and oxygen are inclined to be attracted towards each other. However, there is a barrier in between, which is the proton exchange membrane, which will allow the positive protons to pass through. That's why there is a catalyst which splits the hydrogen atom into positive protons and negative electrons. Positive protons pass through the PEM, whereas negative electrons take an exchange circuit, powering up external appliances, for example the light bulb, then combine with oxygen on the other side of the fuel cell and produce water.
In an automobile, the fuel cells are located in the front of the car, and hydrogen is stored in tanks at the rear end of the car. When a car needs to move, it is supplied to the fuel cell, which generates electricity with the oxygen that is taken in from the atmosphere.
How does the captured electricity move the vehicle? As fuel cells produce very little energy, cars have fuel tanks that contain multiple fuel cells combined together to produce the required energy to propel a car forward. The fuel cell generates electricity and a chargeable battery stores the electricity, which is then supplied to electric motors to move the car forward.
There are totally 6 types of fuel cells, but for transport, the only fuel cell that is used is the proton exchange membrane, as it has an ideal temperature of 75 degrees, which is light in weight, and it has a high efficiency of 60%.
If you compare the waste given out by a hydrogen fuel cell, it is only water, whereas conventional propulsion gives out several bad gases for the earth, such as volatile organic compounds, nitrogen oxide, carbon monoxide, carbon dioxide, etc. Also, fuel cells have a high efficiency of 30 to 40%. whereas conventional propulsion uses much energy and heat loss as well as frictional loss.
According to Honda, a compact gasoline vehicle is 3 times lesser the efficiency of a hydrogen-powered vehicle. A compact hybrid vehicle is twice lesser the efficiency than a hydrogen-powered vehicle.
Fuel cells have a variety of applications rather than just cars. It can be used to power buses and public transport.
It can be used to power portable applications. Over here we have given a military example, and it can be used to power up communication equipment, GPS, and nitrogen goggles.
It can be used at home, where it can be used to power appliances at home, such as TVs, computers, laptops, etc.
Hydrogen can be stored in tanks, and it can be transported by a hydrogen fuel trailer. They can also be hydrogen fuel.
However, as the technology is very young, it needs a lot of government support to improve or change present infrastructure, such as hydrogen fuel stations.
It is very costly when generating hydrogen, as many fuel cells are used, and the catalyst used is flooded, which is very expensive.
There is a lot of greenhouse emissions because commercially, people use fossil fuels to put electrolyzed water into hydrogen and oxygen. But in our experiment, we have used a renewable source of energy, that is the sun, making the entire cycle green and eco-friendly.
State hydrogen storage. As hydrogen is flammable, it can react with oxygen and so on. Researches are still going on how to store hydrogen in a safer way.
However, it has a very high efficiency, operates silently, eliminates pollution, great energy security. We do not have to depend on other nations' fuels, very simple maintenance, eliminates pollution, and aerodynamics is greatly enhanced.
Today, hydrogen is produced from steam reforming of petroleum. It has been used by NASA since 1950s and is still used in the space program. They are stored as cryogenic liquids.
Research is going on with photoelectrochemical algae production as well as solar-powered electrolysis. Few models are there, but more hydrogen car models are coming in. So hydrogen has the potential for solving our energy and protecting pollution crisis in the future. Thank you.
With this handsome demonstration,
You don't like fine.
can you show the actual work here?
Wait. Thank you.
Repeat your name once again.
I'm Sean Michael,
School and
and my school name is Sacred Heart School,
grade.
and I'm studying in grade 9.
I am Nachiket. I am from Sacred Heart School and I am in the 9th standard.